Okay, this question asks about the malonic acid, and it is a diprotic acid because it have two hydrogen here, and it means it can donate two proton. Okay, so if it just like donate one proton, it will have this group left, and this is a hydrogen malonate group. Or if it can donate both the protons, then it just have this one left. This will be the malonate group. And this question A, they say find the pH of a 500 milliliter, just like half a liter, solution that is 0.8 molar malonic acid. So they give us the concentration of the malonic acid mixed with a 1.2 molar. You can notice that the molar here is greater than this one, and this is the concentration of the appropriate salt. So actually here in this question, they don't explicitly mention what kind of salt it is. So I have to assume that it could be either a salt with the conjugate is the hydrogen malonate. So it could be like the monosodium malonate, or any other kinds with the other cation. This is just an example. Or it can be another salt with the conjugate base is this group, the malonate group, and it could be the disodium when we have like two cation here replaced for the hydrogen. Okay, so depends on what kind of salt, we can have different pH. And let's jump into the detail of this one. Here first, we could see that in the solution before adding the salt. Okay, so here this is everything in the solution of the acid before adding the salt. So I could say that first we have a concentration of the acid is 0.8, and then it can dissociate into a proton and a hydrogen malonate group, and then we can see with a chain in X, right? Then here, after solving this quadratic equation, we can find X to be 0.3033 molar. So this is the concentration of the proton and also the concentration of the hydrogen malonate group. So this is like after that first dissociation. So now because we have like some concentration of this one already, then it can start the second dissociation here, and it starts from this one here. So the initial concentration would be this one, and then if it can dissociate a wide amount, then we can see that at the equilibrium we got this one, and then also plug in the values for the Ka2, we can find the concentration of proton that being released from the second dissociation will be this much. Okay, so then after the two dissociation, we can see that the concentration of the acid has dropped, right? Because an amount of it has been dissociated into this one. And then we also see that the concentration of the hydrogen, it can be obtained from the two dissociation. So this will be the amount from the first dissociation, and this is from the second dissociation, which is really small compared to the first one. See, so basically it doesn't really like much difference from this one, right? It's just showing us that yeah, it's not that easy to have the second dissociation, and that's basically the general rule for on-carb acid. And then we also have an amount of the hydrogen malonate left in the solution, because the second dissociation, it doesn't dissociate all of them, so we still have an amount of this one left. So basically in the solution right now, before we add in the salt, there will be the three species, and also of course the water, right? But we don't really care about the concentration of the water, because water is just a solvent, a pure solvent. So here we have these three species, and also an amount of this one as well, right? 4 of them. So 1, 2, 3, 4 in the solution right now. So there will be two cases, right? If we add the salt that is have the conjugate base is this one, the hydrogen malonate, then we can see that this salt, we assume that it will all dissociate into ions, right? Then we have more ions of the hydrogen malonate in the solution. And when add with what we got in the solution already here, then we can see that the whole concentration here is really high and is much higher compared to the concentration of the acid. So we can see that because here, if the product is even more than the reactants, so there's no reason for the reactant to go this way, right? And this reaction will just like being pushed the opposite way, which means that it will just put the reaction of the first dissociation back to the reactants. No first dissociation would occur. And if no first dissociation would occur, then it just means that, okay, the whole concentration of the acid stay the same as the very beginning, 0.8 molar. Then the concentration of the hydrogen malonate ion would just be the concentration of the salt added. And then we just see that, oh, okay, so now in the solution, we just have a lot of this one. So this kind of species, will do what? It will just like go through the second dissociation, right? So then it will dissociate into its conjugate and also release the proton. So that's why we receive an amount of proton, right? Based on the Ka2 constant. Then again, just solve the quadratic equations here. You can find Z here, and Z, that will be the concentration of the hydrogen as well as the concentration of the malonate group, and also we can find what left for the hydrogen malonate, right? So after that, you can find this is the final concentration of the proton. So if we can just simply use the pH equation for this concentration here, this one is a Z, then we find that the pH is around 2.81. Okay, so that's if we add the salt, that which is a hydrogen malonate. What if we add another salt, a different kind of salt, that is this kind of thing, the disodium malonate? Okay, because it doesn't say in the very clearly in the problem statement, right? So again, everything here is the same, right? This is the solution of the acid solution before adding the salt. And now when we add in the salt, we can see, okay, for the salt here, this is the concentration. And now just like twice for the sodium, because we have like two, it can be any other cation. Okay, I just take sodium as an example to make things more specific. And now this is the concentration of the malonate group. Now we see again, this one add together with what we have here from the second dissociation from the acid before, then it will be high again, right? And it's like, again, it's larger than the reactants. So it also means that it will push the reactions of the second dissociation back to the reactant. So it just basically means that, okay, there's no second dissociation anymore. So for now, we will have all of them stay in the form of the hydrogen malonate here. And this is the amount that got dissociated from the original acid. And then we also get the concentration of the acid have been dropped for an amount because some of them have been changed into this one, right? And also in the solution, we also have an amount of this one, even though we don't have the second dissociation, but we have this ion from the salt added, okay? So now we can see that the hydrogen here will is the one that we got from the first dissociation. Okay, this is from the first dissociation, and that will be 0.033 molar. So then we can find the pH to be 1.481. So conclusion, if the salt added is a malonate salt, then this is the pH. Okay, but if the salt added is a hydrogen malonate salt, then this is the pH. Okay, please let me know if you have question. I know that this question is kind of complicated, but if we just like follow step by step and try to see what really happened in the solution, like according to the time in a timeline, then things will make more sense, right? Okay, thank you. And then in the next video, we will cover the last question, the C question. Okay, good luck.